Do you want to give an announcement? Yeah, everybody give Mary a round of applause. Go ahead.
Hi everyone, my name is Mary and I am working on helping organize Startup Week Chattanooga. Just curious, hands up, who has attended Startup Week event? Okay, awesome. So my whole goal is to grow that, so all of you next year this time would raise your hand. Startup Week is coming up October 16th, and that is less than 60 days away, and I'm telling you about it now to plant a seed so you can start watching for the events that are going to be happening. So we are going to have Startup Week October 16th to 20th, and it's over 150 events throughout the week. And one of the misnomers about this week is that it's only for startups, or only entrepreneurs or people who are looking to grow. And we want to help people know that it's for everyone. So if you're looking to grow skills, learn more about what's happening in Chattanooga, come and celebrate entrepreneurism, this week is for you. So I'm telling you now, for those of you who work in companies, start planting that seed in your boss's mind that you're gonna be spending part of Startup Week with us. And then be on the lookout for opportunities to make your schedule and sign up and get connected. So if you have more questions about Startup Week, you can go to startupweek.com. No, startupweekchattanooga.com. So, all right, thanks for your attention.
All right, so next week we've got Will Wade coming to give a talk on metaprogramming, code that writes code, so that's going to be fun. Come out for that. But without further ado, we want to welcome Ethan Rogers. He's going to talk to us today a little bit about continuous deployment and Spinnaker, and that's going to be fun. He's a build and release engineer, right, at Squid. So everybody give him a warm welcome.
Hello? All right. Let me fix this real quick. Can everybody hear me all right? So yeah, like Brett said, my name is Ethan Rogers. I'm a build and release engineer at Squid. I'm going to talk to you today about Spinnaker and continuous deployment. So we can jump right in. So just a little bit more about myself. I am a contributor on Spinnaker. I haven't contributed a whole lot of big stuff, but a lot of small fixes for the Kubernetes provider. And also kind of hang out in Slack a lot all day and kind of answer questions. I consider myself a CI/CD enthusiast, just kind of maintaining CI and CD systems for our product teams. You can find me on Twitter at E_Frogers and on Slack and GitHub at Ethan F. Rogers. So I just want to do a quick survey so I can get an idea of what kind of audience we have. How many? How's that? Good? Is that okay? Perfect. Awesome. All right. So how many of you deploy to public clouds like AWS, GCP? Okay, sweet. Private clouds like OpenStack? Nobody? All right. Kubernetes or Mesos? Squid and Spire. Sweet. Awesome. That's really great. How many of you have actually heard about Spinnaker? Sweet. Awesome. I get to talk about something cool. So during my talk, I'm going to talk about a couple things. I'm going to explain what Spinnaker is, kind of give you a little bit of background, where it came from, what it's used for. We're going to talk about some concepts. Spinnaker has some primitives that model things in AWS, GCP, Kubernetes, kind of ties it all together. I'm going to do a demo deploying with Spinnaker, and we're going to wrap it up. Talk about some drawbacks that it has. So I just wanted to kind of start by where most people are probably at. We at Squid deploy on Kubernetes, so a lot of this talk is going to be focused on Kubernetes. But just know that a lot of the same principles and stuff still apply across cloud providers. So this is what a typical Kubernetes deployment is. You have a YAML file that describes what your deployment looks like, and then it's just kube control apply, my deployment, and your application's running. But as we all know, not everyone's deployment strategy is that simple. Not everyone's deploying a completely stateless app with no database, no nothing. So the next step you might have is say, I need to run some database migrations as part of this deployment. And then your script turns into this. You create your database migration job, you kind of watch for it to get done. Then you say it succeeded or it failed. You might do getting some logs out of there, but you can see that that kind of escalated very quickly. And then, you might say, I need to run some smoke tests. So I need to know until when everything's up, and I need to be able to check it. And your script grows again. Wait until everything's done, and call some Jenkins job that does that, wait for that to complete, and it just keeps getting uglier and uglier and uglier. And then someone comes to you and says, what about canary deployments? How do we do that? What about rollbacks? How do we do that? And you sit there and you look at your tooling and you say, I don't want to write this all in bash. So you try to find another solution. Enter Spinnaker. It offers safe, repeatable deployments, a clear picture of what's running, easy scaling and rollbacks. So instead of having to script all of this thing, it's a totally declarative system. And it integrates with your favorite cloud provider. Since it was built in Netflix, it comes with a lot of consolidated best practices that are battle tested at scale that you're probably not at. Most of us in this room are probably not at that scale. They'll talk about Spinnaker, a quote from the website. Spinnaker is an open source, multi-cloud, continuous delivery platform for releasing software changes with high velocity and confidence. That's kind of a mouthful, but what does that actually look like? It looks like this. Spinnaker is in the middle of all of these things. Kubernetes, AWS, GCP, OpenStack, App Engine, support for DCOS, Mesosphere DCOS coming soon, as well as AWS ECR for those of you who like torturing yourselves. Just a quick bit of history. It was started at Netflix in 2014, open sourced in 2015, led by Google and Cisco and Netflix. Some pretty cool stats. I reached out to some of the Netflix engineers on Slack, just kind of get some information. Netflix runs over 100,000 AWS instances, and Spinnaker deploys 95% of those. And Netflix runs the open source version of Spinnaker as a library and kind of layers their features on top of that. They did 150,000 pipeline executions last month, which kind of came out to 8 million different tasks that each pipeline was executing, which is kind of impressive numbers. It has a lot of really cool features. It has a setup and admin CLI that was just released in Q2. Deployment strategies out of the box, email and chat notifications. A VM bakery if you're baking AMIs. You can do that with Packer. Do it directly in Spinnaker. CI integration, talks to Jenkins and Travis. And Chaos Monkey. Chaos Monkey is pretty cool. Who here knows what Chaos Monkey is? Okay, for those of you who don't know, Chaos Monkey will shoot some of your instances on a daily schedule just to make sure you have resilient software. Netflix does this. They have an entire tool chain called the Simian Army. Chaos Monkey is kind of the smallest piece of that. They have Chaos Kong, which will simulate an entire region outage. That's actually kind of cool. They've done some pretty cool blog posts on that. So let's kind of jump in, talk about some concepts. Spinnaker can be kind of complicated, so hopefully I can boil these down to the simple basics and kind of explain what's going on. Spinnaker's architecture is 9 microservices. The minimum viable install is about 5 with Redis and S3. It's written in Java, Groovy, and Kotlin. Code bases are kind of mixed. You can find more information about it at github.com, Spinnaker. So these are the main components that you need for a minimum installation. Deck is the UI microservice. Gate is the API gateway. Cloud driver is the multi-cloud integrator, and that's kind of where everything happens. Deployment strategies are defined there. Pretty much, if you deploy to a platform, you can look at cloud driver and say, can I or can I not deploy to this? There's a module for it, and it's there. Orca orchestrates calling a bunch of task providers or APIs across providers, different systems. Front 50 is for persistent storage and supports S3 and GCS out of the box. It also supports Redis, but please don't use Redis. I've seen a few people at Slack lose everything because they spun it up on Redis and they didn't know what Redis was. Please don't do that. We've got some bells and whistles, some additional pieces that you don't have to have, but they're really nice. Igor for Jenkins and Travis integration, Fiat for authorization, supports Google Groups and GitHub Teams out of the box. Echo for notifications and cron triggers. Roscoe and Halyard is the admin client. So you don't necessarily need those. A lot of organizations can probably, if you're doing Docker especially, you can run without Roscoe, which could be a system log. You don't need Packer. This is an architecture of what it looks like. Deck and your custom script API caller, those kind of sit outside, and everything comes through Gate. Gate is an API gateway, and it kind of consolidates all the APIs across the services into a nice front end for that. It also has a Swagger UI, so you can discover your APIs and figure out what's going on without having to dig into the code. So we'll talk about some of the Spinnaker primitives. Spinnaker is used to model ASGs in AWS, whatever and the equivalent of an ASG is in Google Cloud Platform, replica sets and deployments in Kubernetes, and it kind of calls all of these things one thing so that it's easy for people looking at Spinnaker to say, I know what I'm looking at. I know I'm looking at an instance. I know I'm looking at a server group. So an instance is just a single VM or container. You might be familiar with this. It's just an EC2 in AWS. A server group is a group of instances. So if we were to look at a picture, that would be an instance. If we were to look at a picture of a server group, that would be a server group. Pretty simple. You see here that I've got something called chadev test v000. And it's important for us to talk about the naming convention that Netflix uses, or that Spinnaker uses, based on a tool called Netflix Frigga. Frigga is used to identify resources, and resources are named by their application, their stack, their detail, and their version. Stack and detail are optional, but they're pretty useful for naming vertical stacks of services. You may have a stack for integration, you may have a stack for staging, and just being able to identify those all running in the same AWS account or a Kubernetes cluster. This is a simple breakdown of what it looks like. Chadev would be our application name, stack would be test, integration would be detail, so maybe you have a integration stack for your test cluster, and your version is your version. Pretty self-explanatory. So what can you do on a server group? Server groups are really kind of where we start getting into what Spinnaker can do. You interact with multiple instances as a whole. We can deploy server groups. We can resize them directly from Spinnaker. We can enable and disable them, which just means pull them out of a load balancer or put them behind a load balancer to serve traffic. We can clone them, which is actually super useful if you're deploying across regions and you've already got one running in US West 2 and you need it in EU Central 1, for instance. You can destroy them and roll them back. And rollbacks are a huge part of why Squid decided to go with Spinnaker. We definitely did not want to script rollbacks. We needed a tool that did all of these things, and Spinnaker was right there. Clusters. Sometimes the delineation of clusters is not definitely clear. It's a logical grouping of server groups based on that naming convention. Clusters can be enabled or disabled. You might have demo app staging and demo app production in the same application. They're just different clusters. And this is what a cluster looks like. Just multiple server groups under different stacks. Applications are logical groupings of clusters. Same thing, it's based on the name, and that is an application. Your testing, staging, and production stacks. It's pretty simple. We'll talk about pipelines just briefly, but I'm going to demo an entire pipeline build, and hopefully that all goes really well. Pipelines are declarative, meaning that you can say I'm going to deploy, this is a deploy step, or I'm going to run my database migration as a job. And you can make these things dependent on one another. They can run in parallel. It's actually like a super powerful tool for doing that. You don't have to write any code. This is what a deployment pipeline looks like in Spinnaker. And then we can see each stage in the pipeline and get some more details. Where this is like super useful, if you were writing a script and deploying like I kind of showed earlier, you have just this giant console output of what's going on. You have like no way to give feedback. You have no way to take any action. Once your script is running, in order to make a change, you probably have to make another commit to a repo, pull those changes in, and hopefully it doesn't break. So Spinnaker is really awesome about giving you that feedback. You can interact with it. And that's kind of what I'm hoping to show in my demo. I kind of rolled through that really quick. Are there any questions before I jump in? No? Okay. Let us go. Can you guys see that okay? I'm not going to really spend too much time in there. I'm just going to use it for some demonstration purposes. One thing I am going to do is I'm going to show the interaction or the integration between Spinnaker and Jenkins and show you how you can call a Jenkins job directly from your pipeline. So this is the Spinnaker UI. Right now we don't have anything. We've got our spin chadev test application, but we don't have anything created. And to do that, the first thing we're going to do is create a load balancer. A load balancer in this case might be an ELB in AWS. In Kubernetes, it's a service. So we can actually create a load balancer. What we're going to do here is say we've got a test load balancer. These are also named specifically according to Frigga. So we've got spin chadev in our test stack. For Kubernetes, we're just going to say anything that comes in on port 80 gets forwarded to port 8000. And we're going to do a load balancer. So everything outside of this little section right here is going to look the same for all cloud providers. As you know, the console for Google is not the console for AWS. There's not really a console for Kubernetes, so it's pretty much just a terminal. And so when you have a team of engineers who are all trying to figure this stuff out, it gives it really, Spinnaker gives you a really nice way of saying, here's some consistency, and here's, we're going to give you just enough to what you need, and then we can keep rolling. So we've created a load balancer. We don't need anything extra. What this is going to do is actually create a load balancer in Google Cloud. I'm using a Google Container Engine cluster to do this stuff. So this is all. The Spinnaker stack is running in Docker on my local machine, but I'm talking to a Kubernetes cluster that's remote in Google. So we can monitor the progress here. And we're done. We have created a load balancer with a bunch of hand waving. So while we wait for a public IP, we're going to go ahead and spin up the first instance of our application. For this demo, I've done just a quick little Go service that has a single endpoint that tells you what version it is and what stack it's coming from. I kind of hope to demo a canary deployment. We're going to build a simple canary deployment here today. So having this stack will be useful in like when we start looking at the output from the API call, it'll be useful to kind of see where we're going. So we're going to deploy our test stack. And we're going to deploy version 3 of our Golang API service. Is the mic all right? All right, I guess we'll keep rolling with it. Check. Okay, this is going to be fun. You guys bear with me, all right? All right, so while he's setting that up, so what we're going to do is we're going to put our server group, which is right now just, nope, that's gone. Yo, hello? Hello?
checkity check. 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 Hello? I can just hold it. It's fine. It's just too far away. This was fine. Yeah, it's all right. Everything's fine. Okay, where was I? All right. What we're going to do right now is we're going to deploy the first instance of our API. Our API is Ethernet for Rogers Golang API service. If for some reason you actually need a container that just spits out a version number, you can use that one. It's out there. We're going to put it behind a load balancer, which means that it's just going to expose traffic. Traffic's going to get routed to it whenever something comes in on port 80, which we defined before. Then we don't need any of that extra stuff. So down here, we're going to configure our container. If you've ever deployed Kubernetes before, you kind of know what a spec looks like. But for those who don't, in Kubernetes, a spec is just a bunch of information about ports and environment variables and volumes that you need. And you define those as YAML, but here we're just going to define them via the UI and declare what we need. Our service needs two environment variables. We need app, meant to hit caps lock. Okay, there we go. We need an app version, and since we're deploying 3.0, we know it's 3.0. That's what we're going to do. We've got one more, that is stack. Stack, and it's our test stack. We know that, so we can just enter it. So that's actually all we need. We just defined our service in Spinnaker. And we're going to create it. So we will sit here and watch it come online. The first thing while it's coming online, let's go grab the IP address of our load balancer. That's our public IP address, and we've copied it. There we go. Did I hear somebody yell out port? Thanks. So we're going to clone this. We're going to fix it. We forgot to add our port. Ports, 480, 8,000. So now we just fixed it. We didn't have to make any commit to a repo. We didn't have to write any YAML. We just said, oh crap, I forgot my port. And we just fixed it right there. That's really useful for, you might be deploying a service and customers are really experiencing some like major issues. And so being able to quickly react is a huge part of what Spinnaker is about. Just, users are important. We don't want to get bogged down in making commits to repos and just waiting for a whole bunch of stuff to happen. With Spinnaker, we can just change that, roll out the next version, and we're good. So V001 actually has our port change. I'll kind of show you guys some stuff here while I'm sitting right here. But each one of these little chiclets is an instance. And it's got some specific information over here about when it was launched, what server group it's a part of, some cloud provider specific information. This is Kubernetes. For us, for AWS, it might tell you what ASG it's part of and stuff like that. We've got some status, some health, the cluster DNS information, labels, information about the container. I'll stop here for a second and explain. This is probably one of the bigger reasons that Squid chose Spinnaker. We had a problem where we couldn't figure out what was running. And that's dangerous, right? If you can't tell what version of the application your users are seeing, what are you going to do when somebody comes to you and says there's a problem? It's probably not head, unless you're doing continuous deployment. So you need a way to figure it out. And Spinnaker says, this is the container you're running. You can even annotate. With Kubernetes, we can actually annotate and say, this is the specific commit that's running. And it's really easy to just quickly go, boom, there it is. So we'll just go ahead and destroy the one that doesn't have the port because that's going to mess some stuff up. So this is the guy that we care about. While that's getting cleaned up, let's build a pipeline. We're going to create a pipeline. We're going to call it deploy. So this is the meat and potatoes for Spinnaker. Everything that I showed in the beginning of a script, we're actually going to be able to build right here, right now, without writing any code. And it's going to be really awesome and hopefully blow your minds. And hopefully everyone wants to use Spinnaker after this. So the first thing we're going to do, I mentioned triggers earlier. Triggers are great. Most of you are probably familiar with triggering Travis builds or Jenkins builds on a repo commit. We kind of have a similar concept in Spinnaker. You can trigger it on anything, cron, git commit, Jenkins, Travis, another pipeline. That stuff gets really interesting. And then a Docker registry. Most of the time, if you're deploying to AWS, you're probably baking AMIs, and you would be triggering off a Jenkins job that exposes some deb or RPM artifact that you need to bake into your AMI. For Docker, we don't kind of have that because there's tons of really good container builders out there, like Quay and GCR has one. So we can just kind of like let CI do what CI is good at and start triggering the deployment as soon as CI finishes. As soon as we've pushed our new image and it is in Quay or whatever registry you want. So I've got mine in Quay. I'm going to deploy the Golang API service. And anytime a new tag hits the registry, I'm going to deploy it. This tag is a regular expression. It's any Java regular expression. We're just going to use .star. If for some reason you keep, tags with like your branch names in it, so maybe you've got a dev and master branch, you can just say master-.star, and it's only going to deploy master, or dev-.star, it's only going to deploy dev. Just kind of a way of keeping things separate. Make sure you don't deploy something you don't want to. So now that that's enabled, anytime a new tag hits our registry, we're going to spit it out. So the next step we're going to do is going to actually deploy our canary. So we've got a deploy stage here. Spinnaker has a whole bunch of deploy stages out of the box. We can check a precondition. We can destroy a server group. We can disable it. Disable a cluster, an entire cluster or a server group. Run a Jenkins job. So actually a lot of these we're probably going to use in this demo. So our stage name will be deploy canary? A berry. That would have messed things up. It doesn't have any dependencies because that's the first thing we're going to do. This is really cool. You don't have to like rewrite everything that you've already written. Or you don't have to like reconfigure everything you've already configured because we can just use it as a template. So spin chadev test1 is the first thing that we've deployed. We can use that as a template. And the only thing that we need to change is the stack to our canary stack. And we'll change the image instead of being the 3.0 image. It's actually the one that we set the trigger up for. So we can say it's not a hard-coded tag. It's whatever is dynamically injected by the trigger. But here we're going to kind of touch on something really cool in Spinnaker. It's pipeline expressions. So pipeline expressions are a way to dynamically inject metadata about the pipeline into different pieces. And anywhere there's a freeform field, like any freeform text field, you can just do this. It was $ curly brace. Here our version is going to be trigger.tag. We're going to inject that as the app version. And our stack is just as easy as stack. So what that's going to do is get evaluated at runtime, and for the canary, we'll see canary. For the app version, we'll see the next tag that we are deploying. And make sure everything's good. We don't have a strategy. I'll touch on strategies when we have actually promoted the canary. All right, so we're good. That's the first step. We'll save that and make sure in case Docker decides to be done. The next stage we're going to do, so a lot of times with continuous deployment, you may have somebody who needs to promote an image to production. You may say, we've got this new version that we just canaried. Can my manager go and click the OK button and say it's okay to ship it? Or yeah. So we'll set up a manual judgment. It's really simple. Does the canary look okay? As part of a canary process, you may actually have to look at some stats to make sure that it's okay. I will say that Spinnaker doesn't support any out-of-the-box canary strategy. There's a company called Armory, which is commercializing Spinnaker, and they offer automated canary analysis, which is really cool. It'll spin up a control and your experiment and talk to, Datadog and Elasticsearch right now, and judge the health of the canary based on those metrics, and you can set thresholds. I think in Q4 or Q1 of next year, Netflix hopes to have some type of automated canary analysis solution built in. So if you need it now, you can pay for it. If you don't need it now, you can wait. Or you can just set these up and kind of do it yourself. So if the canary looks okay, we will be presented with that. Our next step would be Jenkins. We're actually going to not run it after the manual judgment. We're going to run it in parallel with the manual judgment. I did that bad. Deploy canary. So you can see this graph shows us that after the canary's been deployed, it is healthy. We are going to get an option to say, can we promote this? And we're going to run some smoke tests. I'm not actually running smoke tests. I'm just kind of echoing whatever is sent to the Jenkins job. But you get the idea. Jenkins is the stage we're going to run. We're going to configure it. This is our Jenkins master. This is the job that we want to run. If your job's parameterized, Spinnaker will pick up on that and present you options. And you can actually inject, use the same expression language to inject that information. Here we'll just inject the trigger again. Trigger.tag. And we're good there. You can say if maybe you run some tests, and if the build's unstable, in Jenkins that shows up as a little yellow caution sign. You can either fail the pipeline or keep it going. There's just some extra options there. Okay, so once our manual judgment's passed and our Jenkins job is successful, we're going to go ahead and promote it. So we'll deploy. The same thing, it depends on Jenkins. It'll be the same stack, so we're going to override it. So we've deployed our canary. It's running in a separate stack. When we promote the canary, we want the test stack to have the new version. So we don't actually have to change the stack here. The only thing that we need to do is change what the image is. So the template functionality is really good. So if you only have slight variations, you don't have to reconfigure everything that you've already done. And we can add it. And obviously we don't want our canary hanging around anymore because we don't need it. We've already deployed one. We're going to destroy a server group. And that will depend on the manual judgment as well. Or the... Hello? Okay. Sorry, it cut out for a second. And actually the manual judgment as well. So we can say the Jenkins job and the manual judgment both need to be successful before we can promote this. You don't want somebody saying, oh, we really need to get it out. The smoke test failed. We're going to send it out. That's bad. Yeah. I hope nobody has people who do that. So we're done. Actually, destroying the server group needs to be screenshot of canary. And when we destroy a server group, wow. I'm really bad at typing when people are watching me, but with one hand it gets even more difficult. comedic relief. Does that look right? Sweet. I hope I don't mess this up anymore. So with destroying server groups, we can actually do a bunch of cool things like deploy the newest current one. For our canary, that's the one we actually want to destroy. Our previous server group, if we have deployed the test stack already and we want to just destroy it, we're not worried about rolling back to that, we can destroy that one. That was the previous server group. There are a couple more options here. So we're going to do that. I forgot to mention deployment strategies, which is probably one of the cooler things about Spinnaker. We've got deployment strategies. Out of the box, at least for Kubernetes, it supports Highlander and red-black. Red-black is like blue-green, if you're familiar with that. Netflix just calls it red-black because they're Netflix. And if you didn't know, that's the color of their logo. So Highlander will destroy everything. What is that? As soon as the new server group passes health checks, red-black will actually spin the new server group up, wait till everything's healthy, let it serve traffic, and then pull the old one out, but leave it online. This is really good for quick rollbacks. If you already have instances ready to take traffic, you just got to reroute to those instances. So we're actually going to use red-black. We don't want to kill everything. We're going to leave two around, so we can actually just roll back 2 if we need to. We're good there. Yep, we need to change this. Trigger.tag. And our stack is the same thing. Stack. Cool. Our ports look okay, and we're done. Save changes. So, what we're going to do right now is I'm going to kind of prove to you guys that this is working. Make watch. And I forgot to put the IP address in there. Sweet. Go. That's the... No, you don't have to export it. Oh, sweet. That's not really good for kind of demoing the red-black. Hang on one second. Look right. Hey, sick. All right. So this is actually the first stack that we deployed responding. And hopefully we're going to be able to see when we deploy our canary that we start taking 50% of our traffic or somewhere about 50% of our traffic. And we'll get responses from a new version and also a different stack. And then once we've promoted it, we can see it take over. So I'm going to make a new version. Let's see. Crap. So we're pushing a new version of our service up. We can jump back over into Spinnaker and see the pipeline kick off momentarily. And now. And now. Nope, okay, that sucks. What's going on? Anybody know any good jokes? Hopefully not about this talk. Hey, there it goes. Sweet. If we actually had Slack notifications configured for Spinnaker, we would have gotten a notification about it starting. So great, we're deploying our canary. Hopefully this goes pretty quick. All right, we don't have a stack, but that's okay. We know it's the canary. We see our version information here. So we can see that we're getting some responses from the new version. We're getting some responses from the old version. And Spinnaker might take a few seconds to get this. But this is the execution of a pipeline. We got this really nice progression. Here, we can see all of our stages and kind of what state they're at. We can see what we deployed. Spin job dev canary v000 is what is actually being deployed. We can see task status. Each one of these little steps is actually orchestrated by Orca, the microservice that I mentioned earlier. Sweet. That's awesome. I'm so glad when things work. We'll jump over into Jenkins. Session is gone. I think it's already done. Is that the one that 4.0? Man, that's awesome. I love when things are fast. So we have successfully run our smoke tests. If we look in the Jenkins job description right here, we can actually see what the build was. So it gives you a really nice way to jump quickly to which build failed or passed. If you need to see the output, you don't kind of have to guess. And then our manual judgment. The canary does look okay, so we're going to promote it. Let's make sure, one more time, the canary looks okay. Even though our smoke test failed, things can still go wrong. Or passed. They passed. Sweet. So we're on to the next stage of the pipeline, which is the deploy stage and also the destroy of the server group. And this will be really useful. You can see here that we're still taking traffic. Kind of the wonder of Kubernetes that kind of doesn't let unhealthy things keep taking traffic. I'm sure the same thing happens in AWS as well. But with red black, you kind of don't have to worry about that because new instances are not going to get registered with the load balancer unless they are healthy, pass all checks. So we can see now that as part of our pipeline, the canary is getting destroyed. It's been deregistered from the load balancer, which is what this 0% right here is. And it's in the process of getting killed off. We can see here what state it's in and where it needs, like where it's trying to go. We also can see that we have V4 and V3 running. We're still serving traffic. We haven't completely deregistered V3 from the load balancer yet. If we go back into our pipeline, our deploy stage is still running. And we've actually just destroyed our canary. So that container should not be serving anything. And we're getting close to being done deploying. And if we keep watching, we can see that we're no longer serving 3.0 traffic. Pretty cool, huh? Nerd stuff. Okay. So while that is getting finished up, we've got 4.0 in production. 3.0 is this is part of red black. You can see here the instance is actually still online. It's still up. It's still waiting, but it's not behind a load balancer, not serving any traffic. If we needed to roll back, we could very easily do that. I kind of want to wait till this is done. Probably pretty close. Where are we at? 4 minutes and 23 seconds. Usually this one takes about 6 minutes. So if we hit anywhere under 6 minutes, I'm going to be pretty excited. Do what? It is, so Spinnaker does a lot of caching, and so it has to What it does is once it's deployed, it like forces a cache refresh, and then it has to like recache all of those resources to send it. So I think that's probably what it's doing right now. Yeah, it's in this forced cache refresh state. Well, anyway, the awesome thing is it's already online. It's already done. So now we've got our new server group. We're still serving traffic on 4.0, not serving any 3.0 traffic. And then a user comes to us and says, I have this problem. I was expecting 3.0, and you pushed 4.0. Why did you do that to me? You're supposed to version your APIs. All right. So what we're going to do is just like roll it back. Let's see. Yeah, version 1. I was expecting 0. You can also do some type of like reasoning. There are a lot of places in here whenever you do something, you can add a reason. Spinnaker does not have any like built-in audit management out of the box, but you can build your own service and ingest events. At Squid, we did that. We have a service that watches events happen, and we log them all to Elasticsearch. So we have a full audit history of who did what, when, and you can put those reasons in there. So like, I suck. That's why I have to roll it back. And we're in the process of rolling back. And look at that. 3.0 start serving traffic again. And it was fast because we used the red-black strategy. We didn't have to pull the old image down, start it up, wait for it to pass health checks. It's already passing health checks. It's already ready. We just put it behind a load balancer again and fixed it for our users who were expecting 3.0. And the same thing will happen for 2.0. It'll stay behind the load balancer. If we we decide we want to roll forward again. That's it for the demo. All right, so just to kind of wrap it up, I'm going to talk about some drawbacks. A lot of people talk about this on Slack. There are some people kind of doing some work in the community to like make this better. But it's really missing a good infrastructure as code solution. Part of that you can get away with version to S3 buckets. So like all of your pipelines are actually stored in S3. If you turn on bucket versioning, you can get a diff and kind of watch the changes over time. Another one is Spinnaker DCD spec. This is kind of an alpha. It's even alpha at Netflix. But it's just kind of a declarative way to do pipelines as code. You can only deploy to cloud-based stacks like with a Docker and VM. It supports a couple on-prem cloud solutions like OpenStack. I think Oracle BMCS is supported. I think that's what it's called. I just found out about that today. Programmatic API access is a little bit difficult. Since it's written in Spring, if you have Spring security stuff turned on, it has like a default password. That's good if you want to do basic auth, but anything like OAuth and X509 certs kind of gets a little complicated. Again, another thing within the community that people kind of wish was a little bit easier, and there's some work ongoing about doing that. And I already mentioned this, it doesn't have a really good built-in auditing mechanism. And some people may not need it, but some people would. Some case studies that you can find on the Spinnaker website from Netflix and Waze. Obviously, Netflix is gonna love Spinnaker, but Waze is a company that Google bought. You can find a talk from them on YouTube from Google Next from last year where they talk about their using Spinnaker and how well they enjoy it. But they've also done an article here. So quick reference, a couple of things I've mentioned can be found on blog.spinnaker.io. Spinnaker.io has documentation for how to set it up and everything. The GitHub Spinnaker is the main repo. All the microservices are in their own repo, but that's kind of a roll-up. And join.spinnaker.io is the Slack channel. We welcome anyone to join Slack and jump in, ask questions. You'll probably see me floating around there a lot. And that's it. I work at Squid. We're hiring. Go there. Find a job. Thanks, guys.